This is SNN, Least Busted Name in News. Welcome to the Daily Space Weather, folks. I'm your host, Dan, aka smAsho. Today we'll be talking about how there's a solar flare and earthquake watch continuing. A bunch of sunspots in the southern hemisphere of the sun. Thanks to our new viewers, I'm going to be talking about Forum, the smAsho forum, smashomash.com/forum, our solar events logger. So the first thing we're doing is looking at the sun here in 193 angstroms to see a solar flare happening right here just after midnight today on December 5th. Right there. And we'll show you some close-up views of that a little later in the video. The 10.7 centimeter radial flux has dropped down to 96. Here's a one-year chart of it and the sunspot number. Note how correlated they are. And a radial flux of 96 goes all the way back to the year 2016. Since we've seen a radial flux that high, of course we've seen one much higher in the recent days and weeks. We're going to show you one HelioViewer movie here. Here is the 304 angstroms composite along with the LASCO C2, part of the SOHO spacecraft. And then we're going to go through a whole bunch of data. So don't go anywhere. And bear with me, we are streaming live. Today's Smash Lights segment will be a separate video. We're going to stream live once again. It'll be a YouTube exclusive, so if you're viewing on Twitch or on BitChute, tune into our YouTube channel. After we premiere the Daily Space Weather video on YouTube, we will go live on YouTube to talk about whatever we want, which is the standard feature of the Smash Lights. I would invite everybody to visit our social media links and so on below the video. Head to our Facebook page, Entropy Busters, as well as facebook.com/smashomash. And our other social media links. We've got exclusive content on all those locations. And also don't forget to follow me on Twitter. We've got over 3,000 tweets, and that's always interesting. Last but not least, make sure you press like and subscribe on YouTube if you enjoy the content. Share with your friends and foes, and thanks again to our new viewers. Share with friends, foes, science noobs, and science pros the fact that the Smash News Network exists and is continuing to grow into all kinds of different realms. Now we are streaming live to Twitch. It's twitch.tv/smashomash. Thanks to our followers over there. We don't always stream live to Twitch, but when we do, I'm still not the most interesting man in the world. And again, remember, we'll be creating another video here, a live stream, the Smash Lights segment. Today's cosmology segment is going to be random. We're going to roll a 1031-sided die using a quantum number generator. Today's quantum number is 954, and we're going to show you a random object. Random object number 954 on the Neil Gorell Swift Bat X-ray Observatory. 954 is XB 2029 plus 470, a V1727 Cygni object, a low-mass X-ray binary. Here are the X-ray emissions from XB 2129 plus 470. Let's see if we can get a look at it on Sinbad and Aladdin Light. Nothing showing up there on Sinbad. Let's check Aladdin Light real quick. We'll see if we can find it on the 2-mass, which is the infrared spectrum. And we don't want to spend a lot of time monkeying around with this right now, in that we've got some more important data to cover. A very weak solar wind, for example. Let's see if it shows up on the Chandra X-ray. There it is on Chandra. It's also known as V1727 Cygni, apparently. And there it is on the Chandra X-ray telescope. I would also invite all of our viewers to check out smAshomash.com. Our social media links are behind that little drawer right there. And I would also invite you to check out the smAsho forum and the stores. Today's featured object is the Deneb shirt, Cygnus X3. It's available in colors all associated with the blue spectrum of light. And don't forget to enter the promo code smAsho to save 10% at checkout on all orders through Christmas. I would also invite everybody to check out smAshomash.com/forum. Today's featured forum thread is the Solar Events Logger. So check that out. It's part of the Sun forum. If you head to smAshomash.com/forum, again, you can link to that from the homepage. You'll see we've got a forum on cosmology, Earth and geophysics, a free-for-all forum, a general science forum, the Sun, and a forum just for new users. And that's the end of today's cosmology segment. Let's move on here. Again, we don't want the video to be too long. Here's the real-time solar wind. We've seen an incredibly low-density solar wind over the past 24 hours, making it down to 0.1 proton per cubic centimeter. Practically no protons out there in the solar wind. Some small fluctuations here, and we've come off the bottom finally. Still at barely 1 proton per cubic centimeter. Everything else has been fairly stable here in terms of the solar wind, like the phi angle. The BTBZ have started to rock around a little bit, and keep in mind there is a coronal hole wind stream on the way. We're expecting that in about 2 days. Something like Monday, we should see a significant increase in the solar wind density, then the speed. Current solar wind speed, 375 kilometers per second. Let's look at some more data. The KP index. We saw a full KP0 day there. That's actually 27 hours with a KP of 0, a measurement of global geomagnetism. And next we're going to show you the geospace magnetosphere movies. We'll show you the velocity, the density, and the pressure. And we see a fairly stable velocity here. No real surprises happening there. And by the way, if somebody's saying the Integrated Space Weather Analysis Center is not available, I don't know what they're talking about. It's clearly available. Here's the density, and you can see this very low density shown in white. High density shown in dark blue there. And these are, every one of these panes is 4 hours of data. Don't be a pain with your data. Attempt to understand the physics. Dear content creators, don't propagate fake news and nonsense on YouTube. And lastly, we'll look at the pressure, and it's about the lowest pressure perhaps we've ever seen on the channel. Barely any pressure here. And this is measured in nanopascals. And you see a little uptick there. That is that solar wind density increase that we saw in the past few hours. Next, looking at ground magnetic perturbations. And we see a different location here. We see the perturbations in the north closer to the geographic North Pole as opposed to the Canadian at the beginning. And in the south, the main perturbations here are near the actual geomagnetic South Pole, someplace in the southern Indian Ocean there, somewhere south of Australia. And there you can see that little uptick in the solar wind density happening there toward the end. Keep in mind this is changes in the B field, which is why it's listed as delta B. In science, when you see delta, that means change in. And we see the proton flux slowly subsiding here over the past 7 days. There's 1 week of proton flux. There is the 3-day chart that we show daily. And this is the first proton event we've ever covered on the channel. We've got hundreds and hundreds of daily space weather videos. If you want to see what was happening on a previous day, go check our playlist. YouTube.com/smAsho/playlists. We've been doing it for a couple of years. Pushing 3 years now. Here's the 3-day chart for the GOES X-ray flux, and you can see that C-class solar flare that we showed earlier, and we'll show detailed views of that at the end of the video. Here's a star chart for all you spaced out viewers. I use in-the-sky.org. We've also drawn in the ecliptic, and if you're up before dawn, you may see Venus, my favorite planet, which I forecasted via crystal ball to be changing places with Mars. I was vague about it. Here's what's going on in the solar system. And before we do that, let me check the life of the stream here. Allow me to vanish off the screen. And again, thank our viewers, whether you're viewing the premiere, whether you're viewing in syndication, or if you're viewing on BitChute or on Twitch. We thank you greatly for your viewership. Let's advance this 1 week. There's where things will be in 7 days, approaching another new moon, my favorite phase. I'll tell you why in a later video. Next, looking at Lagrange point 5's view to see a coronal mass ejection on the far side of the sun, as well as Venus, swinging around the back side of the coronagraph from the perspective of Stereo A. It's Stereo A's space weather beacon, Coronagraph 2. No Earth-facing coronal mass ejections. And to our new viewers, that's where Lagrange point 5 is located. Stereo A at Lagrange point 5. The LASCO C2, which we covered earlier, is located there on the Discover spacecraft at Lagrange point 1. We've seen a surprisingly level GOES magnetometer here, a very low range of magnetometer readings, which the GOES 16 measures at the F layer of the ionosphere. And we may be snapping into back into the South Pole heliospheric current sheet here coming soon. Let's take a look at the top view of the plane field plot, which is part of the National Sunspot Observatory. And I apologize, the Earth is already in the South Pole current sheet shown here in red. You can see the Earth potential field force line there, potential field surface source line in orange. And this data is gathered from 51 ground-based magnetometers, as well as magnetometers on Stereo A and Stereo B. Next, we'll look at the coronal hole field plot from a line-of-sight view. There's a line-of-sight coronal hole plot. Again, we have a solar wind on the way from the coronal hole in the north, which is actually a south polarity coronal hole. And here's the view, including the magnetometer and the solar Z fields, shown in green and red, north and south respectively. And let's move on to the coronal magnetic field plot. Lots of closed potential field surface source lines in pink. It's showing you open potential field surface source lines in purple for coronal holes, at least equatorial ones. Polar coronal hole potential field surface source lines are in black. Next, we'll talk electrons in the Earth Van Allen belt. We don't see charging hazards. Here's the 1-year chart courtesy Solon.info. And we've seen a decent range here of electron flux over the past few months. And we're expecting a downtick here. At least NOAA is. And I would concur with this. We're going to see the electron flux crater as the coronal hole wind stream arrives in about 2 days. Here's a 3-day chart of the electron flux. No warnings happening there. Here's a visualization of the total electron content forecast, and we're seeing anomalous electron flux regions over North America as well as Antarctica, similar to what we saw yesterday. I'll let it play through a second time. And for you new viewers, this does give you an idea of the amount of GPS error that you'll get. If you see a big yellow blob above where you're located, your GPS could be off by about 50 meters there. And indeed, I've seen situations over my location in Pennsylvania where mine was off by 800 miles. Not recently. And next we'll look at the ionosphere a little more closely. Here is a diagram of the way radiation penetrates the ionosphere and the chemical makeup of different layers. And when we're talking about the GOES-16, we're talking about the F layer. That's where the GOES-16 is located. It's endeavoring to measure at the F layer. Just keep in mind, as solar activity increases and decreases, the size and altitude of these layers also change based on the amount of pressure on the atmosphere. And here is a visualization of the ionosphere, courtesy Australian Government Bureau of Meteorology. Not looking particularly anomalous to me. If it is to you, leave us a comment. A little bit of a charge up there very far south. Here's the latest image coming at you late at 11:15 Universal Time. Next, we're looking at just the de-absorption region, which is the lowest layer of the ionosphere, where the stratosphere meets the mesosphere, folks. And this proton event is causing these polar absorption regions as protons continue to make it all the way down to the D layer. Also, I would note some minor solar flaring there you can see over the Indian Ocean region. And there are some measuring anomalies happening there. Those absorption regions unlikely to be vanishing as quickly as the visualization is showing. And let's move on to see what's going on with volcanoes. Turns out there's a bunch of eruptions. Is it as many as yesterday? Well, let's find out. Klyuchevskoye is erupting. 23,000-foot ash plume. Sakurajima, 8,000-foot ash plume. Suwanosejima, 6,000-foot ash plume. Luatolo, which is the star of the past couple of weeks, still exploding. It's producing a 10,000-foot plume of ash. Semeru, I believe that's an uptick at Semeru. Flight level 140. It's a 14,000-foot ash plume. Dacono also exploding. Flight level 070. Popocatépetl, 23,000-foot ash plume. Fuego, 15,000-foot ash plume as it explodes. Talica, volcanic ash not observed in satellite. Please don't attempt to fly your hang glider over Telica down in Nicaragua, perhaps near Lake Titicaca. Sangay is also exploding, flight level 210, and sporadic volcanic emissions at Sabancaya down in Peru are an indication that it's not a good idea to attempt to fly your John Denver-style ultralight aircraft over the caldera. Earthquake risk continues as we've been seeing a drought of 7, 8, and 9 magnitude earthquakes. Let's scroll up the list. As a proton event is a major risk factor for large earthquakes. Here's a deep one in the Philippines. It's a 4.3 magnitude at over 540 kilometers depth. Right in the middle of the archipelago, too, I might add. Check it out. In the Celebes Sea, there's a location of that. So nothing over a 6 magnitude. Not a lot of deep quakes so far. 4.2 deep quake strikes Japan. It's 113 kilometers deep. A couple small deep quakes struck Alaska there in the 2 magnitude range around 130 kilometers. And a deep quake in Argentina, a 4.6 magnitude at 167 kilometers. Next, looking at the pressure maps here on windy.com, and check out this low pressure system once again over the North Pacific. Yowzers. Those are some extremely tight isobars, massive pressure gradients happening there, and a huge anticyclone there over the northern Middle East. We're going to advance this into tomorrow. There's where we expect pressure to be at tomorrow noontime my time, and I'm located in Lehigh Valley. That's the European forecast. Here's the GFS forecast. Looking pretty similar. And we're going to cover a couple more meteorology topics here. But first, we'll announce our solstice stream. Yes, if you weren't aware, we'll be streaming live at the exact moment of the solstice at 5:02 a.m. Allentown time on Monday, December 21st. Where will you be at 5:02 a.m. Eastern Standard Time? Perhaps we'll be the first channel on the internet to wish you a happy solstice. It'll be streamed live exclusively at youtube.com/smAsho. Next, looking at nullschool.net to see the jet streams. Here are the 250 hectopascal winds of the eastern world. Here's the same data of the western world. And check out the split over the western U.S. as well as over the Atlantic Ocean. 2 major splits in the jet stream in the northern hemisphere. As well as some incoherence in the southern hemisphere. Leave us a comment if you're viewing YouTube channels that are utterly, utterly incoherent and full of Next, looking at lightningmaps.org to see a major lightning storm there in the central Pacific. No terrestrial lightning over the U.S., although some over northern Italy. Here's a GO16 lightning mapper, and we see most of the lightning activity there out in the Atlantic Ocean. It looks like the low clouds have broken up a bit there, as we've been seeing low clouds for a few days. Here's the U.S. Doppler radar map, courtesy Weather Underground. And the rain here in eastern PA is taking its good old time. Heavy rainstorms over the top of my head right now. As well as some snow, according to the radar, some snow at least, falling there in southwestern Texas. A lot of that is probably going to be a wintry mix. How do I know? Because I'm a legit meteorology expert, folks. It all has to do with my cycling background. And my cycling background is what really got me into solar forecasting, as I realized there was more to it than the Doppler radar and the satellite and the water vapor map. Yeah, isn't it funny the way things relate? Here's what's going on in the cloud layer. It's too dark to see the clouds where I'm located, which is why we use the NASA GOES Interactive Weather Satellite Shortwave Radiation Map. And here's the water vapor map of the same area. Some cold air pushing down into the Dakotas and Minnesota and Iowa and Montana and Nebraska as the jet stream is shifting. And this dry air over western Pennsylvania is going to finally push that moisture out to sea into eastern New England. Cloud layer. Water vapor map. Cloud layer. And we're going to zoom in on Pennsylvania here. And shout out to our local viewers. Thanks everybody from Lehigh Valley who has been turned on to the channel. Perhaps we'll consider doing local weather forecasts. If anybody around the world has a weather forecast you'd like us to do, leave us a comment. We'll consider it. Again, we'll be doing a live stream after the premiere of this video at youtube.com/smAsho. Next, I would recommend everybody keep your head and arms inside the SMASH plane at all times, as we've got bonus features, including the solar intensitygram, the colorized magnetogram, and our HelioViewer movies, which we've saved the best for last here at the SMASH News Network. Here's a colorized magnetogram to see degradation of the sunspots in the southern hemisphere. Sunspot 2786 is setting. That's still a significant sunspot there. I think that's 2790. So we see a reduction in sunspots. There's the largest one we've seen in the entire solar cycle. That one is quite decent sized as well. And that one's beta class. There is still significant possibility of solar flares. We saw a lot of radio bursts once again last night. And if you were a patron, you'd already know that. Consider becoming a patron at patreon.com/smAsho. You receive all kinds of early updates, files, etc. And here are our HelioViewer movies for the day. And you can see that solar flare in the southeast in 171 angstroms. Don't worry, we'll zoom way in on that. Again, that happened just after midnight today on December 5th. Here's the 304 angstroms view. We'll probably make another smAshomash.org presents the sun video today, so stay tuned for that. Don't forget to visit the links, smAshomash.com, etc. Some activity there associated north of sunspot 2786 as well. No coronal mass ejections, at least not earthly facing ones. And that prominence splashed back down. Here's just the southern hemisphere. You should get a good view of that solar flare. Let that play through a second time. And then we'll zoom in on two locations. We see some filaments in the southeast, which we'll show you next. Some interesting filaments there in 171 angstroms. It's not a spaceship. It's ionized iron. It's the UV emission spectra of iron, is it iron 18? Something like that. And here's a close-up of that solar flare region. Anyway, thanks for tuning into the SMASH News Network. Remember to stare at the sun. Use the proper instruments like the SDO or perhaps a solar filter. Welcome to the Neo-Renaissance. And since it'll never be now again, may that solar wind be at your back.